Alrighty, today we're talking about ratio tables. Make sure you have your math notes book available and you are ready to take notes because remember, if I'm writing, you're writing. Alrighty, my little meatballs, we're going to continue talking about ratios and we're going to take a look at ratio tables. And no new definitions or anything today, so that's good news, right? But we do need to jump right into it and start working with examples so that you can just see what ratio tables are right away. All right, so we're going to start with example number 1. All right, and we're going to use a ratio table to organize equivalent ratios. Okay. All right. Let's get started. So the first thing we're going to do is we are going to draw a ratio table. Don't get scared. It's really easy. Believe me if I'm not worried about it because, you know, I hate math. I hate art. Okay, so we're going to look at dogs and cats because remember I told you that ratios are numbers that represent two different things that have a similarity, right? So dogs and cats are pets. But they're different because dogs are dogs and cats are cats. Ruff. You get it. Okay, so you're going to draw this just like I am doing it. Okay, and if you need a little bit more time, that's okay. Just pause the video and you will catch up. Okay, so we're comparing dogs and cats. And when I look at a ratio table, the first ratio that I have in the table, remember this is just like a fraction. Think of it like a fraction, okay? Because ratios are special fractions, right? Okay, so the first ratio is usually the lowest of the ratio, and the lowest is like the rate, the very lowest it goes, okay? So my simplified ratio is 1 dog for every 3 cats, okay? So if I have 1 dog for every 3 cats, and now I have 2 dogs, how many cats would I have? Well, how did I get from 1 to 2? To get from 1 to 2, I could say that I added 1, right? But I'm not just adding 1, I'm adding 1 of the initial ratio. So I'm really multiplying it times 2. Okay, so from 1 to 2, 1 times 2 is 2. Well, 3 times 2, because if I do it on the bottom, I have to do it to the top. 3 times 2 is 6. So if I have 2 dogs, I have 6 cats. And if you look at those two numbers, you see they're equivalent because if I reduced, I would come to 1/3, wouldn't I? Okay, now this last one, this one might be a little trickier because I can't multiply anything to get from 6 to 9. Right? There's no number that I could multiply maybe if I were doing decimals, but we're not doing decimals yet. We will. Eventually we'll do this with decimals, but right now we're not doing decimals, okay? So I'm not really able to work from left to right with that 6 to 9 that way. So I have to think, how else would I get there? So what about if I take a look at the 3 and I figure out, well, is there a way I can get from 3 to 9? And I can get from 3 to 9 by multiplying times 3. I'm going to clear that up a little bit, see if I can autofocus and get it a little, that's a little bit better. Okay, so if I do that on the bottom, then I do it on the top, remember times 3, so 1 times 3 is 3. And remember, I can check my math in a ratio table because if I simplify my ratio, this ratio should simplify all the way down to this. Okay, so if I do that, does it simplify? 3/9. Well, 3 goes into 3 one time, and 3 goes into 9 3 times. So it simplifies, doesn't it? So that's how I would do that ratio table. All right, we're going to do another one. And this time we're going to look at pens and pencils. And once again, they have a common factor, don't they? The common part is that they're both writing utensils, but pencils are different from pens. We can compare them with a ratio. All right, so let's fill in our ratio table. And we're going to put 4 6 here. We're going to leave that blank up top. And then we're going to put a 24 here and leave that blank there. Okay, now once again, we're going to try and use multiplication to see if I can figure out how to fill in the blanks, okay? So right here I have a blank. So I can't go from 4 to a blank, all right? And I never want to skip if I can avoid it. So we don't skip if we can avoid it. But right here, I can get from 6 to 12. How would I get from 6 to 12? I would multiply times 2. Okay? So if I multiply times 2 on the bottom, then I do it on the top. And now I get 2 times 4 is 8. And remember, you can check it and make sure that it will simplify down to 4/6. So 8 divided by 2 is 4. 12 divided by 2 is 6. So it is an equivalent ratio. So I know that that's correct, okay? Okay, so now I have to fill in this spot, but somehow I have to figure out how can I get from an 8 to a 24, okay? So from 8 to 24, I can get there, can I? I can multiply times 3. And remember, if I do it on the bottom, I do it on the top. So 12 times 3 equals 36. That's it. There's my ratio table. Again, if I simplify this all the way down to the 4/6, I will be able to work the math. Look, 24 divided by 6 gives me 4. 36 divided by 6 gives me 6. So these are equivalent fractions. Fractions, ratios, same thing. They are all equivalent. Okay, so then my table is good. As long as they're equivalent, my ratio table is good. If they're not equivalent, they can't be equivalent. They can't be in a ratio table because they have to be equivalent ratios, okay? All right, let's try 2 more. And this time I want you to copy it and then try it on your own first. So if you need to pause the video so that you can do the work, that is fine. Okay, and then number 2. Remember, plantains and bananas, they are both part of the banana family, but they're different types. And here I have euros and dollars. And they are both forms of money or currency, but they're different types, because in Europe they use euros and in America we use dollars. Okay, so you're going to work those out real quick on your own. Pause the video and then unpause it and come back to us once you have tried to solve them. And hopefully you will be able to have the same answers when you come back, okay? All right, so for my friends who just came back. All right, first we're going to look at the plantains and bananas. I can't go from 4 to a blank. A blank doesn't help me, okay? So I don't want to use the blank if I can get around it, and I don't want to skip if I can get around skipping, okay? So instead, I'm going to come to the bottom this time, and I'm going to say, okay, well, how can I get from 3 to 6? And from 3 to 6, I can go times 2. And if I do it on the bottom, I do it on the top, just like in fractions, right? So 2 times 4 is 8. All right, now I have the blank on the bottom. So I have to use my top to solve what my bottom is. So how can I get from 8 to 12? How can I get from 8 to 12? Well, it's a little tough to get from 8 to 12. I could do times 1.5, but we're not there yet. We're not talking about decimals yet. So if I can't get from here to there, I'm going to have to get from here to there. Okay? So how can I get from 4 to 12? From 4 to 12, I can go times 3. And if I do it on the bottom, I do it on the top. So over here, times 3. So, 3 times 3 is 9. And remember, if I did it correctly, I can take this ratio and simplify it to 4/3. And so 12 divided by 3 is 4. 9 divided by 3 is 3. So it simplifies. And I can simplify this one to 4/3. 8 divided by 2 is 4. 6 divided by 2 is 3. Okay, next one, euros. How can I get from 5 to 10? From 5 to 10 is times 2. So if I do it on the bottom, I do it on the top. 4 times 2 is 8. Now, can I get from an 8 to a 32? Yeah, I can. I can get from 8 to 32. I do times 4. So if I do it on the bottom, I do it on the top. And 10 times 4 is 40. All right. Now remember, check it. Don't just assume you got it right. Check it. Is there a number that I can divide into 40 and get 5 and 32 and get 4? 8. So if I divide 40 by 8, I get 5. If I divide 32 by 8, I get 4. Okay? So I know I'm right, and I can give myself a big old fat check. Check, check, check. Okay. All right. Sometimes we have to use a ratio table for bigger numbers, and sometimes they can be a little bit more detailed. So we're going to take a look at a word problem. So example 2 is word problems. And you're going to write this down. The label on a box of crackers says that there are 240 milligrams of sodium, which is another word for salt, for every 36 crackers. How much sodium will you consume or eat if you ate 15 crackers? Okay, and if you're still trying to catch up writing that word problem, that's okay. Pause the video and catch up, okay? Once you're done writing that word problem, we're going to start solving it. So, in order to solve it, we're going to use a table. And this one's going to be a little tricky. I kind of like it, actually. All right, so this one we're going to put sodium on top. And when they give us a unit, we usually put the unit next to it just so we know what we're comparing, okay? So milligrams, okay? And crackers. So how much sodium to crackers, right? And they told us in the word problem that we have 240 milligrams of sodium in how many crackers? 36. Okay, and then somehow we have to get from 15. But here's what I want you to do. When you have a really, really, really big, because notice we're going from 36 to 15. So we're actually going down, all right? And that's a little bit harder to do. All right, so what we can do to make it easier on ourselves is take this ratio, and for our second one, we're going to simplify it as best we can. So here we're going to simplify because it's a high ratio when we want to work with smaller numbers. Anytime we can work with smaller numbers, we want to work with smaller numbers. Okay, so I can divide 36 by 12. And I get 3. That's going to give me a nice low number, isn't it? Right? And then if you're paying attention, you know, if you do it on the bottom, you do it on the top. But I have 240 divided by 12. Remember, 120 divided by 12 is 10. And I have twice that. So my top number is a 20. Okay, now I have a nice low ratio. Now I want to figure out 15 crackers, and I'm going back up again now, right? So from 3 to 15, how do I get from 3 to 15? I'm sure you all just said you multiply times 5. And then if I do it on the bottom, I do it on the top, and 20 times 5 is, drum roll please, hopefully you all just said 100. So my answer would be 100 milligrams per 15 crackers. Alrighty guys. That's my lesson on ratio tables. We're going to have to practice it a lot. So, and you'll see this a lot during 6th grade. You're going to see a lot of ratio tables. All right, so go back over your notes. Make sure you got all of it, and then get to work with your practice activity.